Hi everyone. Today we are going to do 11.2 conditional probability. In the parenthesis given. So we are going to find out probability, but conditional probability. When there is a condition, mostly it's there you will see the word given that. So there is a condition. Then what happened? We are going to what happened to the probability? Let's see. So first, let's so we know the probability is fraction, or you can change it to the decimal. A fraction, you have two parts, numerator and denominator. So numerator is favorable outcomes, denominator is what? Total outcomes. And here we need to remember what is the sample space? Sample space, the set of all possible outcomes of an event. So sample space, you are familiar with this word, right? Sample space is what? The set of all possible outcomes of all the event. So let's do the do now. So spinner is here, all equal size sections. So it means each section has same probability. What are the all possible outcomes? It's not how many. So what are the all possible outcomes? Yes, 1, 2, 3, 4, 5, 6, 7, 8. They are the outcomes, right? What is the probability that the number the spinner lands on is odd? How many odd? 1, 3, 5, some. Oh, all the yellows are the odd. So 4 out of 8, which is 1/2. So half. So what is the probability that the numbers the spinner lands on is either even or greater than 5? Oh, we need to write down this now. So either even is what? 2, 4, 6, 8, and greater than 5. Greater than 5, we don't count to 5, right? 6 is greater than 5, 7 greater than 5, 8 greater than 5. But 6 and 8, we already counted, right? 2, 4, 6, 8. Which one is more added? 7. So what are the sample space? How many? 5 sample space. 2, 4, 6, 7, 8. So what is the probability then? 5 out of 8. Yeah, everybody get it? So this one, you just write down here, 2, 4, 6, 8 was even, and which one is greater than 5? 6, 8, but you know that 7 was here, that is greater than 5, so you write down, then it'll be easier, okay? So now let's go to our lesson, conditional probability, but before we do it, let's talk about sample space. Let's see, sample space, a list of all the possible outcomes. So for example, in the spinner, we had a sample space 1, 2, 3, 4, 5, 6, 7, 8. But now another example. Let's say you roll a dice twice, or you roll 2 dice, same thing. You roll a dice twice, or you roll 2 dice at the same time, same thing. So how many sample space? Then in that case, this is the first die, this is second die. Whatever intersect, so when you have a first die 1, for second die has all possible cases, 1, 2, 3, 4, 5, 6 case, right? So 1, 1, the first number is first die, second die. 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. They are all 6 cases sample space. This way, when you change to this one, let's change it this way. 1, now change it to, this is the first, it looks like this, right? And this one is first, this is second. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. This way, how many outcomes do you see now? When the first outcome is 1, you have 6 outcomes possible for the second die. So you have 6 outcomes for the first die. So 6 times 6 is altogether 36 outcomes. So in 36, in the sample space, you have 36 outcomes. Sometimes they ask you to add them, each result, or you multiply. But so 1 times 1 is 1, 1 times 2 is 2. Here is 2 also like this. But you know that there are all 36 outcomes, but out of 36 outcomes, some of them are overlapping, right? But still, you should know that 2 and 2, when you multiply these 2 outcomes, same result, but twice. You should understand. Same result, 2 happen how many times? Twice, right? But now, just remember, these how many outcomes? 36 outcomes. So why we need to know sample space, right? We need to know the sample space. Okay. So they are all 36 samples outcomes. Conditional probability is a measure of the probability of an event. So we up to here we know already, but there is a condition. What is it? So given that another event has occurred. So what happened is, if there is a condition, right, it changes the sample space. It narrows the sample space. Sample space means total outcome. Total will change. Total number will be narrowed because of the condition. Okay? So conditional probability changes the what? The total number. Narrows the sample space. Total number will, denominator will change, not the numerator. So after that, after you change the total number, so denominator, so you narrow down the outcome sample space. Then from there, you find out the favorite outcome for the numerator. So denominator changed, right? Sample space changed. Okay, let's see with the examples. So spinner we already know, but there is, what is the probability of getting a number greater than 5, given that it landed on an even number? There's a condition, given that it landed on an even number. Then when we find out the probability for greater than 5, so we find out the how many outcomes are 5. But do we need to worry about odd number? No, we need to eliminate odd numbers because there's a condition. The condition narrows down what? Whole total sample space. So condition is it landed on the even number only. So our total sample space will be 2, 4, 6, 8 only, right? 2, 4, 6, 8. So given condition, so how does it affect? It changes the sample space. Total, it narrows down the sample space. So so sample space will be only 4, 2, 4, 6, 8. So out of 4, how many numbers is greater than 5? 6 and 8. So 2 out of 4, right? So 2 out of 4. So let's say number 1 case, just if we ask greater than 5, probability 3 out of 8, right? Greater than 5, 6, 7, 8. Greater than 5, 3 out of 8. But if there is a condition, we write down greater than 5. Given that, we write down in this symbol, given that the bar, it landed on the even. Oops, sorry. Even. That's reduce or narrow down the sample space. If it is even, we total sample space 2, 4, 6, 8. Then what is the probability greater than 5? 6 and 8. So 2 over 4, right? 2 over 4, right? Everybody understand? 2 over 4 is equal to 1 over 2. So you see the difference between number 1, number 2, right? There is a condition. What does condition do? It narrows down the sample total number, sample space. So let's try with this example now. The set of data is here through the survey. So different ages. Age group 15 through 18, 19 through 22, 23 through 60. Just, a little bit be patient, please, with this kind of question, but it's not difficult though. So you spend 10 seconds to read, you will have no problem. So 15 to 18 age group. Now, for them, how many times they text message per month? Between 0 to 10, very small number, for only 4 people. 11 to 50, text message, 37 people. And over 50, 68 people. How many all? Or if you want, you can write down the total number here. You add 4, 37, 68, how many all together? 72 plus 37 is 109, right? 109. So now this way you can do also age group 19 through 22, 6, 1150 is 25, over 50 messages 87, write down total here. And age group 23 to 60 is 25, 47, 157. So what is the total number? Total number of people. You should get the total here, 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 and add them all, right? Then you will get it. All right. So this was 109. Second group is 118. Third group is 229. So altogether 456. So I recommend you to write down here 109, 118, 229. And then here, what is in total? 456. So out of 456, what is the probability that the person texts over 50 messages? Over 50 messages, how many people? Only these? 68? No, right? 68, 87, 157. So altogether, 312 people text over 50. So 312 out of 456. And let's go. But there's no condition yet. There is a conditional problem. C. Oops. Here. What is the probability that the person texts over 50 messages per month, given that the person is between the ages of 23 and 60? So we get the probability over 50. We already did here 312 out of 456, right? Over 50 messages. But there is a condition. Given that the person is between the ages of 23 and 60. What did the condition do? It narrows down the sample space. So given that the age group only 23 through 60, we think about only these people, then ignore these two age groups. So we see only this, right? 25, 47, and 57. So how many people are there all together? So we already counted, right? So out of these, how many people do the text message over 50? 157. So answer is 157 over 229. Makes sense? So when you have a condition, given that this the total, the denominator will be changing, right? Will be changing to 2 to 9, right? 2 to 9. So 157 over 2 to 9. And D, sorry, what is the probability that the person texts 11 through 50 messages per month, given that the person is between the age group 19 through 22. So 11 to 50 is 25. But now there's a condition. What does condition do again? It narrows down the sample space to only this group, 19 through 22, right? So we don't need to worry about this age group or this age group. Ignore them. Only see this. 6 plus 25 plus 87 will be total, right? Out of that total, how many? 11 through 50 messages here. 25 over 118. So I think it's better to write down the total number here, right? Then it will be easier. So now you understand about the conditional probability. If not, go back to the the beginning of this video and then repeat. You will be able to understand. Or you can go to the slide and please look at it. Take a look, and you will be able to understand. So just you are going to have a quiz today, and take a quiz in the Google Classroom form. So let's check. So you find the total number, and also in the given condition, you know what happened to the total number, right? It will narrow down to the condition, and then we find the probability. So you have 4 questions in your package. So please finish everything and then email it to me with the exit ticket here. Next slip, I will update later. So I will start here.